Ooh. Hey everybody, this is Larry. This is day 4 of the October Leetcode Daily Challenge. Hit the like button, hit subscribe button, join me in Discord. Let me know what you think about today's farm. And apparently we're doing a lot of water farm. I don't know. Well, I was going to say, do you have water? But actually I have a soda, so I don't know. Not paid, not an ad, so I'm not going to show it that much. It's just Coke. But yeah, for today's intro, I want to talk a little bit about what we talked about yesterday. So definitely watch that video. Probably did because that was kind of a tricky one. But what I was going to say, yes, or I didn't. Well, okay. What I want to say now, though, with respect to that, is that I think one thing that I see a lot of people struggle on, right, in terms of like reaching a plateau, right, like a lot of people, my viewers, my watchers, they're on various stage of progress, right? And some people just get stuck in a plateau where they just feel like they haven't done anything in a month or longer even, right? And I think one of those things that I already talked about yesterday, which is to think about how to improve. You have to grow that self-awareness. You have to think about like specific things that you want to work on, and things will incrementally, cumulatively get better over time, right? And ratings, of course, is a feedback, is a place to get feedback, but it's not, definitive. Your rating will go up and down, and the trend line, it doesn't come apparent until you scale out or step back and look at the bigger picture, right? So definitely don't worry about contest rating to rating and so forth, right? But alongside that, because of the same reason, I just want to point out like a plateau or things that you could get stuck in a local optima, right? I think I talked about this maybe a long time ago now, but maybe not recently, so I'll mention it here, is that there are people who care so much about their rating, they don't improve anymore because they like, oh, I don't want to participate because then it'll destroy my rating. And then, but then at the end of the day, you just got worse because you're not practicing. You're not doing what you want to do. You're not getting the feedback you needed, right? Because you care about a number better than progress. The way that I think about it, of course, I mean, I think that's obvious already, but I was just thinking about this yesterday when I was running my 11 tempo mile, and apparently there's a lot of linguistic things about what tempo miles mean, but basically I'm running at my marathon pace, my target marathon pace for 11 miles. And of course, a marathon is 26 miles, so it's not even half, but you're supposed to do it very tired so that it simulates the last, you're supposed to simulate very tired, right? I think one thing that that you can get into a trap of, right, is that you worry about your time on the clock or on the Strava or whatever it is that people use to measure time, right? And as a result, you don't get better, right? Like, we talked about lifts yesterday, but it may just be as simple as, okay, well, I don't want to take a month off to do weight training because then I may get slower the next time. But again, you have to zoom out, right? When you zoom out, maybe like this is your progress. I don't know. Maybe your progress is a little bit of it, and then like it gets a little bit worse as you kind of do other types of training, and then you become unstuck, right? You become unstuck, and then you actually keep going up. And for me, for tempo miles, for the miles that I was training in yesterday, I think one thing that I was you have to remember what you're there for, right? You have to remember what you're training for. You're not training for a rating. Rating doesn't matter, right? Like, or your rating today doesn't matter. It's your rating tomorrow that you want to improve. And of course, not just tomorrow, but like, farther along tomorrow and so forth, right? Like, and in the context of running, what I mean by that is that when you run 11 miles, it is supposed to be a marathon pace, even though it is supposed to stimulate a difficult 11 miles, especially at the end. It is supposed to simulate the thing that you're supposed to be able to do for 26 miles. And what I mean by that is that I find myself, right, you're running, and you're doing basically more or less for 11 miles, you're doing literally 160 steps a minute times whatever the math is, right? A lot of minutes. So there's a lot of steps, and you're trying to keep your body as straightforward as possible, as minimal as possible, as efficient as possible, so that you don't do as much effort, right? And part of that training, if you don't realize it, it's not just to finish the training, right? Finishing the training is not interesting. Getting your body to do things in a way that you want in the future is why you train, not to win a training, so to speak, right? It doesn't matter if you win a training. Your goal is, maybe it's to interview. Maybe for me, it's my one marathon race of the year, etc. Right? And what happens is that, because as you get tired after all these steps, after all 10 miles, let's say you finish your first 10 and you have 1 more mile to go, you certain parts of your body is just tired, right? Because of, if you're moving the same way every time, it's just repetitive, and you just get a little bit tired. And then and you may see yourself like using other muscles, right? Like maybe instead of, when you're in a groove, when you run at a slower pace, you kind of just glide, right? Because it's supposed to be not that effortful, but when you get tired, you're like exerting it. You're using your muscles in different way. You use it, and you're pushing off more or something. Maybe you slow down your cadence. Maybe meaning fewer steps per minute, but longer steps. Maybe you take a little bit of different things, right? And that's fine if you're trying to finish a race, right? Because in finishing a race, you do whatever you can. This is your one focus, your one target, But if you're training, no, you're not trying to win the training. So focus on your form and focus on and that's what you're training for, right? Or that's what I was training for, right? At the end of 10 miles, I'm still having the same, or as best as I can, obviously I'm training, the same form that I have at mile 1 when my legs are fresher. And so that, even if it's not about hitting a certain time on the clock or watch or whatever. It's about doing the workout in the way that allows you to get out of that local minima, right? Or maxima, whatever, local optima, right? So I think that's the point. My point, in case maybe that's a little bit too much running physiology stuff, but and this happens in other stuff too, right? I mean, with Leetcode and stuff, like strength training, right? For example, as I was telling yesterday, if I'm doing squats or bench, someone asked me about my bench because I guess I gave my squat and deadlift numbers, but at my peak, I benched 225. Not gonna lie, I maybe I could have gotten more, but I was just like, two plates on each side, I'm good, I also need to give people kilograms because people are more metrics. So, but you have Google, you have calculators, you'll figure it out. But yeah, so that. But anyway, my point there is that if you, it's the same idea, right? Which is that with Leetcode, which is that if you pull full strength every time, it may work in the beginning as you're learning how to even just use your muscle in general, right? You have this linear growth. But at a certain point, you're just going to plateau no matter what. Right? I mean, no matter what, you're going to plateau because that's just, limitations of a lot of things. But also, if you just do 1 pound every week, that's 50 pounds a year. And in like 10 years, you'll be benching 500, which obviously doesn't, there are other, things about it. But, you just do the math, it doesn't make sense, right? Like you can't gain like 1 rating per contest, and the next thing you know, you had like 5,000 rating or something. I don't know, whatever, right? But the point is that, but even just aside from that, if you keep on doing full strength, you just like your body just can't handle it, right? You're beating your body too much. You have to let it kind of do other things. And also, when you're talking about these strength training things, right? A lot of it is full body, right? Like a squat. It's not just about one muscle. It's not about, it's about coordination and processing of a lot of different muscles working in concert at the same time to kind of get you down and then up and then all these other things, right? And sometimes, you may just have a little bit like, I don't know, for example, maybe someone might not have strong ankle flexibility, which is a weird thing to, I mean, it's not weird, but in the sense that if you're not familiar with squats or something, maybe you'll be like, what does my ankle have to do with squatting, right, etc., right? But the point there is that you have to find your weak point and then take time off, not time off, but just like, rotate, work on other things, so that now when you get back to your main goal, you're able to break out of those plateaus, right? So those are the things I want to kind of talk about in terms of, I gave you 2 examples with running and strength training. And I gave you an example yesterday with respect to Leetcode, right? Like just, for me even, right? Sometimes I do work on, it's fine, and then I need to work on harder problems every day or whatever. But at some point, sometimes myself, not like a hypothetical me, like I would work on speed, right? Just so that I can make sure that, okay, I'm able to solve the easy parts. I want to make sure they stay easy, and if they stay easy, then I have a chance to solve the harder parts, right? So those are kind of the things I want to talk about. All right. Once again, I know that I said this yesterday, and people did comment, and I appreciate it, by the way. But if you listen up to this far, leave a comment, because I don't know, I probably should. I also have another channel that talks like more like what I call the inner game, right? Which is like how you think about approaching these things and attack these things. I need to record more videos, but nowadays I've been just so tired from marathon training that I have not been able to do that. But leave a comment if you'd like to see that. Leave a comment if you resonate with what we talked about today so far, and how it relates to you, and if it helps you, and in what ways it helps you, and and maybe even comment with what you want to work on next on Leetcode, and or your physical training, or both. Always happy to engage and chat, and of course join the Discord and all those things. Yeah. Okay. Another long intro. I am gonna. Today is my easy day, by the way. I didn't run yet because I don't know. Oh, I wanted to eat to so that I wanted to eat enough so that I'm kind of more recovered from yesterday before I do my easy run. It's a easy 5 miles, so I'm not really worried about it. I could do that while like napping or something. But yeah. All right, let's take a look at today's problem. We have 11 container with most water. English is a little awkward, but all right. You're given an integer array height of length n. There are n vertical lines, such as 2 endpoints I line I0 and I height. Okay, yeah. Find the 2 lines that together of the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Note that you may not slant the container. Okay, I mean slanting is fine. I'm trying to. I think the first thing I'm just wondering is whether like going through stuff is okay. Like, why is there like a black thing in the middle, right? Like, do we just like ignore it in that case? Okay, but in any case, I assume that we can just ignore it. Let me bring up my drawing thing. This is actually kind of related to what we was doing yesterday, right? Except for the easier version, the 2D version, with height maps, I always call it, I don't know, I call it this 1D actually, but obviously with the height is a 2D, but I don't know. Maybe I'm just thinking stuff, right? So I was just taking my drawing things up, right? I think the first idea that I might think about, right? Why is that not pasting? Am I doing it wrong? Oh, there we go. Yeah. Oh yeah. First thing I just want to point out, and I just took a peek now, n is 10 to the 5th, just so that we're on the same page. That n squared is not fast enough, because if n squared is fast enough, then I'm like, all right, let's take away the drawing boards and then write 2 for loops. But since it is not fast enough, then we have to play around with some ideas. I think this is a classic, what I would call a sweep line contribution problem. Contribution, because then now we can maybe, sweep line is just what it sounds like. I think that one's more obvious. You go from left to right or right to left. It doesn't really matter. A lot of problems you can kind of see the symmetry very easily, and I think this one, the symmetry makes sense, right? In that, like, it doesn't matter which way you go, because if you want to go the other way, it's just you go to going forward but flip and you have the same answer, so it shouldn't matter, right? Okay, so then now the way that I say contribution is because then now, as we go from left to right, we look at each divider or whatever it's called, and then from each we should calculate the most, or well, to be more specific, first we say what is the contribution to the answer of this, if this is the right right as in left right, not correct. If this is the right side of some sort of subarray, or in this case the right side of the divider, and then you have a left side to the left, then what is its contribution to the answer? It doesn't have to have a real, like, it doesn't have to affect the contribution, but it could have its own interpretation of the contribution, right? Because in that way, if you're able to get the max for this cell or this this divider, then now you get the max for all the dividers, right? By the sweep line, right? And if you get the max of all the sweep lines, then you're able to just get the max of the entire answer, right? So that's why I kind of break it down to contribution of like one at a time. Okay, so then now let's say we have one at a time, right? What are we looking for? Well, there are two ways to think about this. Maybe necessary. You'll see that a lot of times I don't. I mean, it depends on the problem, I think. But sometimes I do, sometimes I don't. And what I'm going to say is about optimization, right? In that, in general, you probably don't want to prematurely optimize. And sometimes there is a simpler answer if you do more proofs. But for me, I don't always do that because it's not always necessary, right? And what I mean with respect to this particular problem is that let's say we have here, right? Well, if this is the right side, then there may be maybe there are two contributions, right? There may be like either the tallest or the shortest, right? Meaning that maybe another way to phrase it is that if we're looking at here, and this is the right side, then either this is the taller one or the shorter one. And maybe there is a way to do it so that you don't need to do taller and shorter, and there is. I'm going to mention it in a sec. But if but I think if you're in a contest or an interview situation where I don't want to prove anything, then we'll just do both, right? But for this particular problem, it turns out that you can solve this problem twice, right? As again, what we said earlier about the symmetry going from left to right. If we say, all right, going from the right for this particular divider, we want to say this is the taller. Then now if we flip it around, then this divider is going to be someone else's shorter, right? So that's kind of the idea to think about. So then as a result, then we don't have to, that's just less code to do, right? Because then now we just assume that this is taller. That means that we only consider lower dividers to the left side, right? Because then now in the future, when you flip it and sweep the other way, then now it'll be it'll be someone else's lower or something, right? Hopefully that makes sense. And then as a result, then now how are we drawing this, right? Well, I think the visualization is important, and the idea would be that, okay, well, we just kind of, and this is not quite how I would implement it, in the sense that there is an invariant that we have to, or we should take advantage of, but this, just as a kicking off point to kind of visualize it, I'll go, okay, well, where do we go here? Well, then we have this water thing, right? And then now we go here, and now this has this water thing. And keeping in mind, though, that because this is taller and farther away, right, the area is obviously bigger. But the invariant is also that as we do the sweep from left to right, just as a note, that means that in the future, if we have, let's say, another one thingy here, right, another divider here, then we never really want to consider this one, right? Like this one is no longer a possible answer because it gets dominated by this one, right? Because, yeah, I mean, you could just draw it. You got to do this, and then or do this, and obviously you want the bigger one because it's totally like a subset or a rectangle or whatever, right? And this is kind of how the structure behind monotonic stacks and stuff like this. Well, stacks in general is because then now you're eliminating things that could never happen, right? So you don't have to check it again because it can never be better than, like, this rectangle will never be bigger than this rectangle, right? This rectangle could be because you can imagine that, you know, it depends on the height and the width, etc. So maybe this could be bigger than this, right? So you have to keep that. But then now here, come here. Now you're okay. Well, look, you just draw it as visual. All these rectangles are subsets, right? Or sub-rectangles. So we can remove it. And again, same for here, right? And this is how you kind of let me step back for a second. So this is how you construct an invariant, right? Is that as you go from as you sweep from left to right, as you look back, you just be conscious about removing things that are impossible. Note that everything that I've done so far, I mean, I did kind of spoil it a little bit by mentioning monostack, but none of it depends on the fact that it is monostack. So where does the monostack come from? The monostack just comes from the fact that, can I unwind too much now? Okay, give me a second. The monostack comes from the fact that if you kind of, let's just say we have this really long, kind of messed up drawing. Oh, what the technology? Let's say we have this really long one, right? The monostack just comes from the fact that if you have to consider, say, this rectangle, right? Or this, well, in this one gets dominated by this one, right? And then this one, and you could see that here in a stacky kind of way, that this is bigger than this is bigger than this, right? And this is kind of, I mean, you may notice it and maybe it comes in handy in certain harder problems, but this is just an observation that, oh, it turns out that it is monotonic. But as you can see from our construction, it doesn't have, I mean, it's a chicken and egg type thing. I wouldn't say that it doesn't have to, but that's not a premise, right? We don't go, oh, there's this monotonic property, that's why it works. No. There's this invariant where we just, for example, now that this one is bigger, then we don't have to consider these anymore, so we could remove from them. It's not because this number is bigger. It's because, I mean, it is kind of because it's bigger, but because this the visualization is that this rectangle makes it so that the smaller rectangles no longer make sense, right? So that's kind of what I want to get at. And from that, I think we should be able to just conjure up a problem, right? A solution. We already have a problem. And maybe we'll do what's it called, a scan, right, of height, right? And let's just say this is going from left to right. For each eye, we want to look to its left to find the best shorter divider, right? And that's basically the idea. Maybe we'll just put it in here. Maybe it's a little bit more reasonable. And then you have a stack, right? For h in height, we can say, right? Well, length of stack is greater than 0, and stack. How do I want to do it? All right. Well, first, maybe I just missed a step. Let me think about this for a second. I mean, I talked about, I got to the monostack, but then what I did not do, actually, so I lied or am wrong, is that, okay, now that we kind of have this, how do we construct? And also I did this backwards, so my fault, actually. I think what we want to do, okay, I think I confused myself a little bit. I mean, the idea still is true for a lot of problems, but this one is a little bit more tricky, or just different. Um, because then now, let's say, actually, let's say we have this data structure, right? And now we're looking at, let's say we're looking at this, right? And we're just given this data structure and it's already constructed, um, you know, right? Then now the question is, okay, given this, what is the best area, right, that we can get? Um, and that part I forgot to answer. I mean, it happens. Let me drink some liquid soda. Yeah. Mm, I might even have it the wrong way, didn't I? Mm, this is a medium. Am I doing it wrong? I mean, apparently. But I mean, I think there are a couple of ways to do it, but I don't want to do it that way. I mean, one observation is, for example, is that this is that as a result, these rectangles are binary searchable, so you could binary search, and that takes advantage of the monotonicity, monotonic, monotonicity of the thing to get the maximum area. But I don't. I think that's like a little bit complicated. I don't like that answer. Let me think. Right. So the question is, okay, let's say you already have this data structure. You have this, and you just have these heights and the indexes, right? And we assume that they're all lower than this thing. But is that true? Maybe I'm just confusing things. But yeah. Hmm. Man, I don't. I mean, man, maybe I just don't know how to do anything anymore. Hmm. Yeah, I don't know that one. Hmm. Maybe this. Give me a second. I am not. I have to recollect myself. I think one of the hardest thing to do in Leetcode is, or just competitive programming and problem solving in general, is maybe admitting that you're wrong. And it's not even necessary that admitting you're wrong. It's that you have to reset your mind so that you're open to new solutions. I thought that I had this. To be honest, maybe I was thinking of a different problem that's similar. I don't know. But I think I interpreted this incorrectly. So my apologies if that's the case. We'll see. How else would I think about it? Do I want to? No, because this one can. But this assumes that all the things are smaller than here, right? That doesn't even. Does that even make sense? Maybe I'm. Hmm. What am I doing? I think I'm wrong though. I mean, no. I mean, I think you could binary search, but I don't like that answer. I don't. I feel like there's a simpler one. I think I'm like that. That's a very maybe not very, but it's a reasonably complicated thing to do, or like the understanding for this one. And what am I doing wrong? Huh. Yeah, the hard thing is like resetting everything and starting from scratch essentially. But then you already have this like bias in your head, and you're like, well, how do I do it, right? I don't know. All right, let's refresh. I think that was wrong. Or it's for problem. Not. I mean, I'm thinking of something else. I must have been. But okay, so let's say we have now I have to brainstorm again, start from scratch, kind of thing. Okay, so maybe we don't do contribution, we don't do whatever. Then um, the way to think about a lot of these problems is just trying to reword it in a way that you have the tools to solve it, right? And so what does that actually mean? That's a good question. Okay, so let's say we let's just say we have this right side, right? How do we figure out what is a good left side to do? I mean, we did it kind of before, but you don't want to, because the reason why that binary search is fine, but yeah, we're just not able to kind of, maybe there's a another way though, right? Because okay, so let's say we have this. Is there always an optimal? I mean, there's always an optimal. Well, the thing that I was noticing, and I couldn't quite express it, is that okay, before we had like this monotonic thing, right? But the thing is that once this number is selected, change the card real quick. Once this number is selected, this number actually cannot be anymore, right? Why is that? Is because when you go to left one, it can only have this much height, while this one can have that much height, right? So then as a result, once this is better, then this is also no good. So the only way that this is okay is if this is the best. And as a result, then the invariant actually is just that if this is the right side, then we just have a pointer somewhere right on the left. We go, okay, is this good? No, then we go to the next one. If it's higher, then and the area is such a way that it makes up for it, then this should be then we move to the next one, because everything to the right of it would have like I said, like you can increment by this much or this much, and this much will always be less than this much. Oops. And so that means that we're done there, right? Okay. Okay, I think I believe that. So then now it becomes, I mean, so that's the invariant. So it's like it doesn't even have a stack. I thought it was going to be a stack because of, and you could binary search kind of, but actually it is simpler than that. But that is hard. For yeah, wow. So then now it just becomes a sort of a sliding window type thing, right? And it doesn't. I don't know that we have to look for shorter anymore. Just look for best, right? So then now we do for right in range of n. That's just the right pointer, right divider, and then now look to the left. We say it's left is 0 to 0, right? And we just have a best 0 to 0. Then now, while left is less than right, No. Does that make sense though? Man, sorry friends. I found these water problems. I'm the water of my worries. I got nothing. That's terrible. But oh, let's try something else actually. Because I was trying to do a sliding window, but I don't think that makes sense either, right? Because okay. Well, maybe it does actually. Let's see. Right. So let's say we start with here. We go to the next one. We go here, and then this is the triangle, right? Or the rectangle. And now we go to here. Then what? I mean, then now it goes either here or here. And what if it's this one? Then I guess it's fine, right? So then we have to consider whether, I mean, on the while the right keeps going, we like, how do I know whether these two rectangles, which one is bigger, right? I mean, obviously it depends on this height, but this one is just so much more. Like, how do you know when to replace? I suppose that's the question. Maybe the sliding window doesn't work then. I think that's why I had to like step back out, because I didn't know how to replace. Like I was like, maybe you could replace by looking at here, here versus here, but I'm not quite sure how to draw the relationship, especially with this, right? Okay, so we have to find another invariant. Man, I feel like every time I give a speech in the beginning, I'm like struggling with the problem, and it's like, well, don't do drugs, kids. This is what happens to you, or whatever. I don't know, right? All right, let's start at the end, right? Let's say we have these two, and then we just have this triangle, right? Then now what? Then now we're trying to move to a smaller triangle, right? So then now, okay, maybe we can do something like that then, right? We could compare, because we know that we have to shrink. This reminds me of a problem that we had the other day, but compare this versus this maybe, and as a result, I mean, obviously this one's bigger, but I'm trying to figure out then what's next, right? Then now we have either this or this. But how do you compare that versus someone like that, right? Like, how do you know that's not the case? That may be a consideration in the future, or even did I mess that up? -2, so maybe it just goes here. Right? Like, how do you know that that's not? I see. You definitely do, because all subsets of these, well, all subsets containing with this as the left endpoint are going to be smaller than all the left endpoints here, right? So that means that this will never be a possible answer, so you can eliminate it, right? Because no matter how far you extend it as a subset, it is going to be smaller than this extending it to the left as a subset, no matter what, right? Like, even if we have higher ones, it doesn't matter, because, right? And that is just because this thing is shorter than this thing. And then, okay. I think that's it. The visualization is tricky though. Hey, wow. I don't remember this one being hard, but I mean, I'm ever done peak week almost. Nothing is easy anymore. But okay. So then now you have the green parts, and then now you compare this versus this, and again, of course, you choose you choose this one because here every subset that extends will be a superset of this, right? Because the visualization is that you could shift one over, right? And then you'll see that it is just strictly bigger no matter what. And as a result, then those are not possible. So maybe you would have something like, maybe you would write something like left is equal to 0, right is equal to n-1, right? So then now, well, right, then, and maybe best is equal to right minus left plus 1, that's the width, times the minimum of the height of 0 and height of, well, technically left and right, right? Because then that's the current area. And then now, while we still have a length, then if height of left is greater than height of right, then that we keep left and then right, else it did the same. I think it doesn't matter. We increment by 1, and then we just do this thing again, and then we should be good, I think. Hopefully. I was hoping. Wait. Is that not the right? Why would it give me 8? Because at the very least, if left is good, then we move right. No, that looks right. But all right. I'm just dumb. I copied and paste, but what I need is this is max, right? I set the base. It's been a long day. Okay, I mean at least it's wrong, but it's wrong in a more reasonable way. And also, I think this I just missed by 1, because actually the distance is this. Okay, that's YOLO submit because I'm tired and I'm right. Okay. Yeah, I mean this is kind of a rage. I mean. All the ideas were the same, right? Like from the first time that we did it, with what I said about invariants, and everything made sense. But it's just about finding the right invariant. And apparently there are a lot of different invariants in this problem, and not all of them matter. I think there is a binary search solution, but I think that's like a very tricky one. I guess this is about, yeah, actually, now this is the one that I was thinking of, actually. Yeah, this was the one I was going to write, but I like, that's what I was saying about like going left, right, and then mirror, and then binary search. But I didn't like that answer. Apparently, I did do it 4 years ago. Wow, that was a long time ago. But yeah, I don't like that answer. I think it's a little bit maybe too hard. But apparently, that's the way that I've done it all the other time. So maybe that's just the way that's more natural to me. But I thought today, for some reason, I thought that there should be a user solution, and the invariant is hard, right? And I don't know that because I'm fresh off messing up a couple of times. I don't know that I explained it that well, but I'm going to try one more second or one more attempt, and you let me know if this is good enough. All right, why is it not pasting? Oops. Okay. The idea here is that, okay, we start off with the rectangle that goes all the way around, right? Oops. We start with a rectangle that goes all the way around. Okay, we're Gucci. And then next, we want to basically try to, we start with L, where, let me write it here. L is equal to N, right? Or N minus 1 technically for the width. And then now we want to go, okay, what if L is equal to n minus 2. So here there were only 2 n minus 2 ones, right? You have this one that goes this way, and then you have this one that goes this way, right? So the purple is L is equal to n over 2. And if you just kind of mentally shift the bottom one over by 1, then you'll see that it actually goes, you know, where the green is, right? And then the idea there is that, well, any subset of the green, no matter, will never be as big as this. So we should just throw this endpoint away, right? Because all of this is going to be smaller than here, no matter which subset. So that means that, or another way of saying is that if when we're trying to do L is equal to L n minus 3 next, well, there are only 2 n minus 3 within the green. It could be either here, something like that, or this is a terrible color actually. Hang on. So it could be either red is terrible too. Not running out of colors really, but whatever. I'll just do it here. So it can only be up to either here or here, right? But both of those are going to be smaller than what's the subset on this top, no matter what, because it's just this chunk versus this chunk, but with a higher possible ceiling, right? So that's kind of the invariant and then you gotta keep going, right? Because then now we remove those, so then now we do n minus 4, and then we just consider the bigger pieces. Yeah, if you kind of visualize it that way, then all the components are smaller than the other ones, and so you eliminate one set of them every time. And that's basically it. I mean, the complexity, this is going to be linear time, linear space, which is better than my other n log n one, which I was kind of, apparently that's the way I keep on gravitating toward. I don't know. But yeah, I am tired now. This is a very long video at this point. I thought this was going to be a quick one before I go for my run and maybe a poop. But that's it. That's all I have for this one. Have a great weekend, everybody. Stay good, stay healthy, do good mental health. If you watched it all the way to the end, one more thing is that I just watched Peacemakers, season 2, episode 7 at this point. Let me know in the comments what you think. No spoilers though, but man, what an episode. Anyway, all right. That's all I have for this one. Have a good weekend. Have a great weekend even. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.